So welcome back to another, what I think is going to be not only an interesting but exciting panel and hopefully an engaging panel. So right off the bat, if there are any questions out there, anytime you've got a question, please raise your hand, wave your hand, jump up and down, whatever it takes to get our attention. I'll bring the microphone over to you and we'll get your questions answered. We've heard a lot of comments about some of the things that have traditionally been somewhat deterrent in terms of businesses, service providers, just the communications community in general, moving towards new technologies, security, scalability, resiliency, things like that. But what we've also obviously understood is that all of those things are most definitely needs, requirements for the service provider community in order to move forward, in order to become more flexible, in order to meet the needs of an evolving digital customer base. We heard some interesting comments regarding assumption of failure when designing networks versus building for and ensuring 5 nines reliability. What it all really comes down to is how does the service provider community leverage COTS hardware in a way that they're going to be cost effectively managed, they can be flexible, they can be scalable, all while achieving these things: security, reliability, resiliency, availability. So what we want to do now is talk about how some of those things are going to be achieved, what are some of the things it's going to take in order to reach those goals, what are some of the limitations of commercial hardware. Joining us on today's panel are Sharon Barkai. He's the co-founder of ConteXtream. We've got Les D'Souza, the senior principal consultant at Tech Mahindra. Probably the second shortest commute today.
I'm sorry.
You probably have the second shortest commute if you came from your offices down the street.
Oh, actually, I'm from from Dallas, but I traveled overnight, so I was here. So yes.
Got it. And we have Kevin Riley. He's the Vice President of Platform Engineering and Engineering Fellow at Sonus Networks. Gentlemen, welcome. I want to throw one quick question out there to each of you, also give you a chance to kind of make an introductory statement to our audience. We heard a comment earlier from one of our speakers that effectively service providers are not going to run their networks on commercial servers. Do you agree? Do you disagree? Why or why not? Sharon, we'll start with you.
Sure. So actually, when we started ConteXtream, when we started to vet the concept, we went from carrier to carrier, and most of them told us they will never, ever run infrastructure on standard hardware. So why did we pursue? We figured that the carrier is kind of locked between the demand of the users and the abundant low-cost supply of the internet players. So eventually, carriers will have to align themselves to the practices used by the Netflix and those giants that people talked about in the last session. There's not going to be any choice. And the question was how can we, ahead of time, was pre-SDN and NFV, can help facilitate that transition for carrier conditions, which is they don't write their own apps, mostly, and they are a lot more geo-distributed. They cannot just be under a waterfall in Norway, okay, and then serve the rest of the world. So what can we do to facilitate carriers to that kind of a clustered, elastic, map-reduce practice for high capacity, low cost, high availability, quick rollout? And that was our thinking, and this is what we're about.
Les?
Yeah, I think the question of using commodity off-the-shelf servers and when that will be realized as a goal, although it's a goal of SDN and NFV to have such environments and use them in practice. transitioning from purpose-built or even servers that were specially built for carriers. In the past, historically, carriers always ran their apps on special servers, hardwares from certain suppliers and certain OSs, and they were hardened kind of environments. So transitioning from that to running it on commercial servers is going to be a period of time over which SD and NFV proves itself. So they've got a period of time over which they will validate the premise that such commercial systems can truly deliver the performance that vendors who ship them out claim they will. And that validation cycle will ultimately result in them accepting and running stuff on it. As some of the speakers mentioned earlier this morning and afternoon, there are aspects of running these services on such commercial hardware that are related to the software that runs on them. So purpose-built systems had specialized hardware and some software on them that made them perform. Whether it was performance in terms of throughput or performance in terms of reliability, scalability, there were certain aspects of built-in capability that allowed them to perform. Those aspects there are vendors already working on translating those similar capabilities to be available on these commercial platforms. So that once those aspects are also integrated into this whole system, which is built on commercial components, they will start performing and delivering the capabilities that carriers expect of their systems, and then they'll start rolling them out with confidence. I think that's.
So at Sonos, we make telecommunications infrastructure, and we sell to many of the tier ones service providers worldwide. And to echo Sharon's comment, 5 years ago, they were locked in on purpose-built hardware. That message has shifted significantly as we work closely with our customers. I think several large service providers have come out publicly and announced that they are moving to a fully virtualized core, leveraging SDN and NFV where appropriate. You have AT&T with Domain 2.0, which has been announced as a fully virtualized offer. Deutsche Telekom has made a similar announcement. In reaction to this and working with our customers at Sonos, we've effectively virtualized our entire product portfolio to follow our customers down this path. Carriers and service providers are not going to snap their fingers and move everything to COTS day one. There are several challenges. What they're going to do is they're going to look at each network element and decide how mature the technology is and how appropriate it is to move that application into an NFV environment. For each one of these network components, there's going to be a trade-off, right? Efficiency, you'll take an efficiency hit because you don't have specialized hardware anymore, or you have to engineer more componentry around resiliency in anticipation of failure, because COTS won't have obviously doesn't have the same resiliency as purpose-built carrier-grade hardware in some circumstances. But for each one of those network elements, the carriers will look at the trade-off between flexibility of being on COTS versus efficiency. An efficiency haircut in getting there. And they are migrating their network elements today. And I think another proof point for these carriers is that they also have, especially the tier ones, have enormous IT infrastructure. And that's as mission critical to them as their outward bound services. And that infrastructure has been fully stabilized in a virtualized environment. And a lot of those ideas, methodology, and architecture is now flowing into their service offer. So they've proven it out in their IT world. There's an amount of confidence there, enough empirical data that has them convinced that they can take this onto the service offer side. It'll be a gradual transition where eventually, hopefully, all the network elements get there. It'll probably play out over the next 5 years, but the transition is starting today.
So really, Kevin, what you're talking about is sort of a partial virtualization of the service provider network. How then? First of all, is that the logical approach? And how do service providers prioritize which which of those network elements are going to virtualize, and secondly, can they achieve the level of scalability by going through this into a partial virtualization environment, or do they really need to get to almost a full virtualization?
Good question. So I think certainly for Sonus, we're very focused on real-time communications, and that is one of the challenging areas in moving to COTS and moving into a virtual world. There are certain aspects of real-time that are difficult when you move off of purpose-built hardware where you use specialized chips and componentry onto COTS. So some of the areas that are probably not ideally suited to move right now are things like digital signal processing, processing media, doing things like transcoding or running video conferencing. These applications are extremely compute intensive. Intel devices, they're great at rendering video graphics and doing vector processing, not great at doing digital signal processing today. So the efficiency flexibility trade-off for media processing is probably still not where it needs to be to drive scale on COTS. That being said, there are other areas where there's challenges that you can solve on COTS. Networking, Intel has made great strides on COTS servers and being able to classify and forward an enormous amount of bandwidth on standard COTS. You can go, 3 or 4 years ago, 10 gig was a big deal. Now people are pushing 40 gig through COTS and effectively doing routing and switching. So this gradual transition, in some sense, it helps the scale story. It's how you optimize scale today. You look at the components in your network. You determine which ones can migrate to COTS, to virtualized infrastructure, which ones are too compute intensive or have too high of latency and jitter requirements that cannot be met on COTS today. You leave them on specialized hardware where they're most efficient. And what that does is that allows you to actually maximize your scale at this point in time. Because if you tried to cram it all into COTS, you would have to overspec your hardware so much to meet the real-time constraints that it would be harder to scale or more costly to scale. By taking out the pieces that are ideally suited to move to COTS and moving them in that direction, recognizing and identifying the pieces that are ideally suited to stay on specialized hardware for the time being and leaving them there, you actually have an optimal scale, an optimal scaling story. And as COTS evolves, you slowly migrate those functions that are on specialized hardware into the COTS domain when COTS catches up. So it's a very logical scaling story to start that way.
Les, you're nodding your head. You agree?
Yeah, I think I completely agree with what Kevin said. There are functions that there are certain kinds of applications that are already well proven in the enterprise space, transaction kind of applications and things like that, which are very well proven. These kinds of applications straight away, then those kinds of services can be straight away virtualized, and you can get the scales that you need. The functions that traditionally are linked closer to data plane and require heavy kind of throughput and processing, they also can, with some support, like was mentioned in the morning, you can basically build NICs that do a lot of those kind of heavy lifting and work very well with the VMs and applications that run on the cores on the COTS platforms. Do load distribution and do those kinds of functions so that basically they take care of some of the compute intensive, the kind of functions that in purpose-built systems were implemented in the kernel or very close to hardware. So with a mix of such environments, you can have basically implement a platform on which you can then virtualize a broader spectrum of services.
I think since we got started at 07, our story is the migration story. It's how can we survive? It's because there's a lot of steps you do in between point A, all mainframes, to point B, all clusters. And so for us specifically, the value proposition that we decided to focus on is to build sort of like an SDN overlay, which is a patch panel for NFVs. You can just patch them in, and the traffic will be mapped to the right function based on load, on subscriber, or sequence of functions. So NFV is just starting to deploy. So how come we already deployed? So one migration option that has been deployed in production tier 1 is to connect the monolithic IMS cores as if they were virtualized. So what does that give you? Well, it gives you, first of all, immediate 50% reduction in the amount of capacity you need because you do not anymore build for local peaks, and you do not have to replicate big chunks for high availability. The next thing, once you created that indirection, that thing in the middle overlay, you can start to virtualize some of the IMS cores. Or let's say you have 5 or 6 IMS cores. The 7th one can be 100 VMs, and that will be completely transparent to the subscriber. So that's one way to start skinning that, that problem, and has been done. Another thing which I heard is done, which I relate to, is start with low-hanging fruit. So, for example, in mobile carriers, what we have done the past year, we deployed flow mapping, 50 billion flows a day that take on the GI functions, which is a bunch of stuff, like a Chinese menu of protection and analytics and header enrichment and transcoding that can be virtualized quickly. And I think that's the steps people have to take to get comfortable with the practice of how you start to do these migrations, how you compensate for less performance with higher utilization and global availability. So there's no doubt that purpose-built hardware is faster than COTS. But when you take a lot of these functions and put them on a router, what happens is that they run at 50% utilization at best, because traffic is mapped topologically to that router, and it changes loads during the day. In addition, there's another one next to it which is doing nothing. Okay, so you're down to 25% utilization. So as soon as you say, okay, not that practice, the practice is going to be clustered map reduce for what I can do first, like GI functions or IMS or things that are easier. Then it's, of course, arranged completely differently. And it starts with the way you think about it, even though your components are the same as the ones you used to. Traffic comes in from access, is mapped to clusters or monolithic or legacy, and then reduced back to internet, and the same on the way back. So that's just a different way of thinking about it without even changing. There are difficult problems in virtualization. For example, the EPC problem, which everybody is interested in, which because of the nature of mobility, any user at any point may be hooked up to a virtual or non-virtual EPC component. And that's a catch-22 or a lockstep that the industry needs to get over with, and it does it by doing these steps, a step at a time.
So you're talking about really the relationship between virtual and purpose-built in terms of utilization and performance, which it almost sounds to me like you're talking about a zero-sum gain comparing the two.
Actually, yes. It turns out to be, you end up where you started, but you end up with the operational efficiencies and fast rollout and change of practice and pricing structure that enable you to go to the next step. So yes, it's a step. It's a zero sum in a way, but it positions you for growth versus not a through street. Nice point.
Kevin, you mentioned earlier about some network functions that may not yet be suitable for virtualization because of some of the limitations of COTS hardware. What are some of those performance challenges and limitations?
For sure. So the first one I mentioned was digital signal processing.
Right.
It can be done in a virtual world. Our product, we have both. We do it in pure software. We do it on purpose-built hardware. Certainly the Intel processors, they're not DSPs. They don't have the specialized hardware assist to do things like running codecs for compression or running modems for sending fax over internet. Approximately, DSPs are about 5 times more efficient than an Intel. If you just compare the cost of a clock against any given algorithm, it's about a 5x cost hit to move those algorithms onto COTS hardware. You could do it. The algorithms themselves are about 50% as efficient. The Intel chips are about 3 times more expensive than a DSP, so you end up around 5x. It can be done in Intel. We do it, and again, you have to take that you have to step back and say, do I want to trade off efficiency for flexibility? Other areas for real-time communications that come under pressure on COTS are exactly what Leslie said, heavy media processing. So in a session border controller, we have to provide security on all of our interfaces, which means we have to protect against DOS attacks, malicious endpoints peppering the box with small attack packets or replay attacks at line rate. So you need to be able to handle minimally sized packets at line rate for the interfaces you support. That adds up very quickly in a packet per second rate that you need to handle and swallow on a server. It can absolutely be done, but there are tricks you have to play. Certainly, in a pure virtualized world, if you just drop in your app and say, I want to protect 1, 2, 3, 4 gigs worth of interface and provide full security and DOS protection, you'll be hard-pressed to do that on a server running standard VMware network interface drivers. But there is emerging technology that's coming out in the industry that a lot of the industry is getting behind to support hypervisor bypass on technologies such as SRIOV that allow you to actually connect to the physical interface and work around the hypervisor layer in your virtualized environment so that you can get those packets into your application as efficiently as possible without a lot of overhead tax and process those packets almost at line rate or at line rate. So there's kind of a category of functions that I'd say is not well suited yet to scale in a virtualized environment, which are those heavy math functions such that would typically be implemented by a digital signal processor. Functions that are typically implemented by a network processor, like packet classification, forwarding, denial of service protection. They can migrate into the virtualized world, but you really need to look at doing it in a way, you just can't do it the obvious way. You need to think about the cost of moving packets in and out of your application in a virtualized domain and look to leverage some of these emerging technologies or develop your own because it is a significant tax to just drop in heavy packet forwarding into, say, a VMware environment and just assume it's going to work. So those are probably the 2 biggest areas, I'd say, that where you take the biggest haircut and pay a big tax.
Leslie, if Sharon's assertion is accurate that right now we're talking effectively about a zero-sum gain when we're talking about utilization versus performance, and Kevin's right in that there are a number of network functions that just aren't ready for virtualization, where are we headed?
So, I think, we've all realized that there are gains to be obtained from virtualization in any case. I mean, if you can move certain functions out of purpose-built, systems, and we've seen this happen in the past as well, right? I mean, you had previous steps. If you look at the evolution of from the old days where you had integrated class 4, class 5 switches to intelligent networks where you spun off stuff into SCPs, and then you moved into voice over IP where you split hardware as media gateways and soft switches. There were gains to be obtained from doing each of those steps. So I think, moving out, doing part virtualizations and also taking steps to use accelerators like, Kevin was mentioning, that are coming from these vendors who provide the components for the COTS platforms. taking those steps and having virtualization on simple COTS platforms or on accelerated platforms are the initial steps that you would have to take to in this whole journey of virtualization. But it's not like just because you cannot virtualize everything and put everything on commodity servers that you don't take the steps. Since there are gains to be obtained from it, you take these steps, get the gains out of what you can do, and wait for the next step in technology that takes you to the higher performance. There's still going to be purpose-built systems that the moment you have devices that start having 64-bit processors on them and start generating bigger traffic, and you have bigger pipes that are going into 80 and 160 GB and all of that are growing, those challenges will still need purpose-built systems to address. So there will be a higher-end performance of network functions that still have to be addressed by purpose-built systems, but there will be a segment of applications that you can start migrating to NFV, SDN kind of systems and use the benefits you get out of it.
Do we have any questions out in the audience while we have a moment? Kevin, yes, you were saying.
Yeah, I was just going to comment on the response. And I wanted to touch on a point that Sharon mentioned earlier. Even though we say it's a zero-sum game, and I agree with that, but that's really from a performance view.
Exactly.
Right? The point that Sharon brought up briefly that bears repeating is that a key aspect of this new architecture and moving to COTS is it does allow service providers to roll out services much more quickly in a lower touch way. And that has very high value. The number of IP services that are being rolled out is ramping extremely quickly, especially as if you think about it as wireless network providers go to all IP with LTE. IP service is ramping very quickly. The personalization of those services is ramping very, very quickly. So even though the performance might get you to kind of where you were with specialized hardware, you've now unlocked an architecture that allows you to drive value. So it's not about making the pipe cheaper or making the pipe fatter at a lower cost. It's about driving more value through the pipe, and that's what this architecture helps unlock.
I would have to agree with that. The baseline is that you cannot be less overall cost efficient than purpose-built because there's too much resistance for such a move. But once you have PARD, then and exactly as was stated, the OpEx and rollout and top-line benefits are enormous. So in our first big Tier 1 rollout, we even had to sort of hide the fact that this is COTS from the operational people. The architects knew all about that. They knew they were building a bridge to cloud. But the operation had to see the solution as a box, as a blade server. It had NFVs and other software. Only when they thought, oh, in this site we need 2, and in this site we need 3, and here we want the box here to back up the box there, that they began to feel that this is not routing, this is clustering, this is an overlay. And when the next opportunities occur for, let's say, revenue sharing, okay, by profiling, enriching, and performing analytics, and that's already in production, that's when the marketing people begin to see that this is the way forward. So there's no doubt that we're going towards a clustered world. You'll walk into a POP a few years from now, and there's going to be just servers, routers, and switches. No special anything. The question is, what is the wavelength of this trend? And there's good business moves to do in every step of the wavelength. And I relate to the comment about moving from class 4, class 5, and then IN, and to ATM, and then broadband. Every one of these took about 5-7 years. It looked like it's taking forever. But then when you look back, the world has completely changed in 7 years in a world which is considered tectonic, but it's really, really fast if you look back.
Les, talk about some of the strategies that you've employed with regards to service assurance testing and such when moving into a virtual environment.
Yeah. So in terms of testing and validation, the validation cycle, in the end, every system that is deployed by a service provider, it's got components, it's got pieces that all collaborate, do a function. And then you look at performance aspects of it. So functional aspects and interoperability and all are steps of testing that a service provider normally employs. This whole testing and validation process starts from, right from the service provider being aware of the design aspects that lead to performance. So they've got to be cognizant of all the facts of each component, how it contributes to performance. In an end-to-end performance evaluation, what kind of budgeting would be there for each component and how each component plays a role. So every service provider will have to model the kind of performance that they're looking at, and they'll have to be aware of how all these piece parts collaborate to deliver that performance. Now, when you're doing testing and service assurance, of that whole system, and this is going to be complex because, we are talking of performance of NFV and SDN being derived from orchestration of this whole system and replicating VMs to address dynamically the performance requirements of the system. So it's not just putting pieces together, but dynamically orchestrating them so that you deliver an end-to-end performance when you are in runtime. So what service providers will have to really do is basically take the platform on which all of these services are going to be built. So we've got this whole base platform of servers, hypervisors, VMs, and all of this. They will have to first characterize the performance that these platforms can deliver. So they probably have test applications that run and on these platforms and characterize their throughput, characterize their scalability, availability, and all of that. The next thing would be to load applications. Vendors, when they provide applications, they will have to really give indication of what kind of performance those applications meet. And service providers will have to do performance testing, and vendors will be aware that the platforms on which they are running can deliver this kind of throughput and all. So when service providers run this, they will have to use traditional approaches of injecting traffic, timestamping the whole process by which transaction runs through the system, and really identifying bottlenecks. As we discussed in some previous sessions, the service providers and system integrators are going to be the ones who now take the place of engineers who used to build the purpose-built systems. So they are going to play those roles, and they'll have to use similar techniques to isolate issues and bottlenecks and uncover performance issues, really.
Sharon, you've been through some of this migration process. What are your thoughts on considerations?
I would echo exactly the last comments. We see it, for example, for testing for high availability. So it's COTS. MTBF numbers are completely different than the routing boxes. So people have to internalize what does that mean. It means that at any given point, 20%, 15% of the servers are being upgraded for new NICs, for new firmware. There's constant, it's a very fluid environment, which means that how am I going to put it as a highly available solution? So the whole practices of virtualizing the network using MPLS, VPNs, and VLANs, that doesn't hold very well in such a fluid environment that everything constantly moves. The VM moves because I have to upgrade. The user moves because I changed the port. And therefore, you need the underlying infrastructure that supports all aspects of testing for distributing the load for performance, but also for the flexibility of everything. Everything just moves. It's not the exception, it's the rule.
Obviously, service providers, just like everybody else, are in it to make money. What does the whole concept of moving into a software-based environment do for the price performance paradigm in terms of moving from a scenario where you've got traditionally hardware that becomes amortized and you have software, various software revisions running on that hardware, as opposed to now moving into a situation where you've got software that's sold per CPU supporting hardware upgrades. Kevin, you want to take a shot at that?
Sure. So you're asking how does the model change from a
Yes.
service provider point of view?
Yes.
Okay. So for them, they view it as obviously they view it as more flexible because they want to go there, right? So for them, they look at it as this decoupling now. Instead of having to kind of bolt down a piece of hardware and ride a software curve on a piece of hardware and be constrained in a certain footprint on that asset in their network. Now it's a piece of relocatable functionality, and they can independently drive the underlying technology and move that functionality around and instantiate it on whatever footprint best suits them. It's no longer dictated by the vendor. So the vendor doesn't come and say, okay, I want to sell you a router. It's this cage. These are the number of cards that go in it. There's a certain value associated with it. It's basically built for the worst case scenario. Whether or not the service provider needs all that capacity, it's engineered with, say, a 5 terabit backplane, and the service provider has to pay for that. When you break the coupling between the application and the hardware, the service provider can now go out and right size their hardware platform on COTS appropriately and maximize kind of their investment or minimize their investment such that the application is now running on hardware that is ideally suited for the performance and scale point that they need to meet for that application. And if that changes in the future and they need to scale out, it's just a matter of relocating that application to a bigger server or a more powerful server or turning over that hardware. So it gives them that independence to scale the application and right size the application without the vendor dictating certain hard boundaries.
Sharon, I know you have thoughts on that.
Yes, I think I would agree almost 100%. So it's a very different world where in the previous world, I used to buy a BRAS or a DSLAM, and I knew I'm going to sell this access service for that capacity of subscribers, and that's going to be my model here, my ROI. Or I'm going to buy this IP router with MPLS, and I'm going to sell VPN, IP VPNs, and that's not the case anymore. The situation right now, the stress of all you can eat bandwidth and demand and lowering and competition reminds a little bit of what the airlines needed to do to survive. And they need to do a lot of things. There was no one silver bullet. They needed to increase utilization, so we're all now cramped in those planes. They started to do these annoying bags charging. The pamphlets in front of us are paying for the fuel. Okay, it's joint marketing. So there's a range of things that are constantly needed to be done. And so there's the indirection now. From a box to an ROI, I'm going to a different model, which is right now, for surviving the next year, I'm going to have to do speedy proxies, and I'm going to have to do this revenue sharing and blah, blah, blah. And then I go to a software giant like an IBM or Oracle in the enterprise space, and there's something similar it's going to emerge here, maybe the existing SIs. And I'm going to specify a bunch of options that I need. And they're going to be driven by multiple ISVs that are going to supply these components, and they're going to have to roll out now, not be investigated this year, spec'd next year, roadmap the other year, and turn up 4 years from now in a box, which then I'm going to turn on, and then they're going to reduce my box throughput by 50%. That's not going to work anymore.
Les, so we've heard a little bit about the limitations of COTS hardware, some of these changing business models. Are these things that service providers should be afraid of, or is it something they should embrace based upon the flexibility? And really, what I really want to get at as kind of a closing question is, how quickly are some of these challenges going to be overcome in terms of moving into a closer to a full virtualization environment?
I think the comment that was made this morning about crawl, walk, and run kind of thing is, and what we've seen in previous evolutions that have taken place is that they basically have got their, they take their time in terms of rollout. In terms of opportunities to the service provider and what they bring, the kind of flexibilities and the kinds of new services that can be created on such platforms makes certain new business models available to the operator. For example, since a lot of it is going to be software driven, the service provider could go in for a model where they say, okay, now we've got all these partners who are providing all of this. Join us in that business. So make these partners, these vendors who offer their software services on these platforms, make them as part of the whole business case, have them basically obtain their revenues out of the revs that are ultimately obtained from the service provider. So it opens up business models to the service provider where they can really make these software vendors who supply these platforms, make them as kind of the over-the-top users of this network, and take rev share out of what they pay them. So basically, it's a rev share model that can come out of all of this.
Kevin, how are some of these limitations impacting potential timeline of this migration?
Well, I think I agree. It's kind of, while there are hard limitations out there today, I think those limitations aren't quite where most of the customers are on the curve. They're still, they're still very, very early, and they're going to pick their safest applications to start virtualizing first and get comfortable with the model. Things that are transactional at very low frequency or not even transactional. I think it's fun to talk about taking the entire network and running it on COTS and imagining a world where you're dynamically load balancing and turning up and turning down services based on demand and moving things across geolocations. But the way I believe it will start is it'll be mostly static. People they'll start prototyping this on lower risk applications that are probably deeper in the back office, not so close to the edge where real time is critical and mission critical, and it will be mostly static. And as they start to build that infrastructure up, you'll see kind of the virtualization creep towards the edge and get closer to the real time applications. And hopefully by the time it gets to that edge and the service providers are serious about virtualizing real time processing at the edge of their network, those gaps will be closed, and it will be efficient enough to move those functions into a fully virtualized model. So I think this kind of split model is good for prototyping and starting to build the architecture and define the architecture. But when you get out a few years or down the tail where you're into a mode of full turn-up, that gap will probably be closed, and kind of the segregation between purpose-built and COTS will probably be less important at that time, once the carriers are comfortable enough to move there.
Sharon?
Yes, I think I totally agree. There's lower hanging fruit, and it is the last resort of turnkey. And just as Kevin described, it's going to be step by step. I agree.
I have a small thing to add there. One example of a POC that we are doing with the service provider is where we are basically deploying a proof of concept, CDN kind of rollout. So all these elements of platform, CDN, cache implementation on this in an NFV environment. And in that particular POC, we are also coupling it with their SDN stuff. So, there's a kind of 6 to 8 month cycle that has been defined of where we do selection, build of platform, and test of this whole environment. And they hope to arrive at an assessment of performance and this thing, and that would lead to a cycle of that defines the kind of rollout of that whole service.
Excellent. Kevin, Leslie, Sharon, thank you so much for being part of this conversation. Everybody out there, thank you again for being here. We're going to take about a 10-minute break, grab something to drink, stretch your legs. We're going to be back in here in 10 minutes for our last two keynotes of the day, after which we'll have our network reception out in the lobby again. Thank you. Thanks, gentlemen.
Thank you very much.